Hello, everyone. Welcome to week 5 of your lecture notes. And as for this week, which is for the week 5 lecture notes, we will be looking at the topic called sound. Now, so far, just some minor reminders. Please ensure that you are attempting your lecture-based quizzes. Your quiz 1 has also been up on Moodle. Now, I am recording this video right on Monday, week 6. However, I hope that you have attempted your quiz, for which you were given a complete 1 week time to actually attempt it. So I hope you have done that. So what you will need to start doing next is start preparing for your mid-semester exams, which will be scheduled for the entire of week 7. So please start up with your revision. You can also have a look at the mid-semester exam layout, which is up on Moodle. Let's quickly just show it to you. So this is what the layout is. Okay, so if you look at your mid-semester exam, okay, the layout has not been fed onto your my assignments at the moment, but you'll have a 20 marks of multiple choice questions, 20 marks of 20 marks of short answer questions, and 10 marks of true or false questions. That is what you will have for your mid-semester exam in CIN535. Now, let's hop into our lecture notes. So like mentioned earlier, this week we will be looking at the topic called sound. Now, perhaps sound is one of the most sensuous types of elements in multimedia. When we say sensuous, the word sensuous means it affects senses rather than you using your intellect or brains. It is a meaningful speech in any language. So this is what sound is. It is a meaningful speech in any language. And sound can generally include from a whisper to a normal conversation or to a loud scream. So this is what all a sound constitutes of. So in this set of lecture notes, we will be looking at the introduction to sound. We'll also look at what digital and MiDi audio is, and then we'll compare them in MiDi versus digital audio. We'll also record and edit digital audio just to show some elements in it. And you look at the different types of audio file formats and adding sound to multimedia projects. What are some of the elements that you need to consider while doing so? Introduction to sound. Vibrations in the air create waves of pressure that are perceived as sound. Sound waves vary in sound pressure level, amplitude, and in frequency or pitch. Acoustics is the branch of physics that studies sound. Sound pressure levels, loudness, or volumes are measured in terms of decibels. Now, when something vibrates in the air by moving back and forth, it starts creating a wave of pressure. When it reaches a human eardrum, you tend to experience something called as a sound. Now, when you look at the term acoustics, this is a branch of physics whereby sound is very clearly studied. Moreover, sound pressure levels are measured in terms of decibels. Digital audio. Let's go and read out the points and then I'll summarize it right at the very end. Digital audio data is the actual representation of sound stored in the form of samples. Samples represent the amplitude or loudness of sound at a discrete point in time. The quality of digital recording depends on the sampling rate or frequency rate, that is, the number of samples taken per second. So digital audio is created when you represent the characteristics of sound wave using numbers, a process referred to as digitizing. Let me repeat that. When we say that we are creating a digital audio, is just a matter of we representing the characteristics of sound wave using numbers. So that entire process is called digitizing. Now, how is sound digitized? Okay, so how is sound digitized? It is digitized through the use of microphones, to the use of synthesizers. When we say digitize, how do you actually start putting in sound in your computer system? Digital. Remember, you have uh, digital. There is something that is in the electronic mean. Okay, so how do you digitize sound? Microphones. We have synthesizers. We have existing recordings. We have live radio. You have television broadcast, etc. Now, digital sound is sampled sound. So when we talk about sample sound, is a quality, okay? Well, sample sound is just like an nth fraction of a second. That's sample sound. A nth, that means a single fraction of a second is the sample sound. The quality of digital sound depends on the sampling rate, also known as frequency. So the sampling rate is usually measured in terms of kilohertz or thousands of samples per second. Digital audio. Digital audio is device independent. The value of each sample is rounded off to the nearest integer, which is called quantization. Now, digital audio is device independent. That is, the quality of the audio is based on the recording and not on the device. Quantization is a value of each sample rate rounded off to the nearest integer. So since digital audio is actually represented in terms of numerals, or when your sound wave is converted into or represented by numbers, so therefore quantization tries to ensure that each of the sample is rounded off to the nearest integer. Crucial aspects for preparing digital audio files are, so when you're making or when you are preparing digital audio files, what are some of the crucial things that you need to consider? Balancing the need for sound quality against available RAM and hard disk resources. Setting appropriate recording levels to get a high quality and clean record. In other words, when you are making digital audio, it is fairly straightforward. Okay, so how do you make digital audio? Is you plug in a microphone, you use a audio digitizing software to record and make a digital audio. Some examples are Audacity, Adobe Soundbooth, and so forth. And when you're doing it, you need to consider some crucial aspects. High quality usually means larger files. So that means when you have larger files, it will require longer time period to download these files from the internet. And thus, more storage space is generally needed. Therefore, you need to balance the quality of sound against the RAM and hard disk resources. Moreover, you also need to set proper recording levels to get good distinguishable sound. When we say distinguishable sound, is more like you're actually able to make out what the sound is. So if you are trying to record a sound whereby a person is singing, so you should be able to distinguish very, very carefully what are the words the person is actually calling out, or the person is actually speaking. Once a recording has been completed, it almost always needs to be edited. Basic sound editing operations include trimming, splicing and assembly, volume adjustments, and working on multiple tracks. So we will look at some of the basic sound editing operations. First of all, we look at trimming. Trimming is just a removal of dead air from a sound. When we say dead air, the blank space. So when you are, let's say if you are recording a sound and there is a blank space, okay, so you try to remove that, which we also call it as dead air. So that's the process of trimming. Splicing and assembly is the removal of extraneous noise that creeps into a recording. When we say extraneous noise, it's just like something that is extra. For example, when you're recording a sound and then from the background we hear a dog barking, so you try to remove that barking sound. So that is an example of splicing and assembly. Volume adjustment is when assembling various recording, there is more chance that not all recording will have the same volume. So volume adjustment is used for such instances. Okay, so let's say you are recording sound and let's say a person is singing. So the voice section where the person is singing, sometimes the throughout of the voice, that means when the person is singing, the volume may be differentiable. Now that's very much common, because when somebody is singing, sometimes the voice levels or volume levels may go up and down. So this is where you adjust it in volume adjustments. And then you have resampling. Okay, so these are also some additional additional editing features. Okay, so in additional editing features, you have resampling or downloading, fade-ins and fade-outs, equalization, time stretching, digital signal processing, and reverse sounds. So resampling or downsampling is the editing of sound sample rates. By resampling or downsampling, example, recording the sound at 16-bit, but you are using a lower sample rate for your project. Now, what it simply means is that you are editing the sound sample rates. Now, what is a sound sample rate? In this case, so the sound sample rate is generally is the quality of sound, okay, the quality of digital sound, that is sound sample rate. So when you are trying to edit the sound sample rate, you either resample or downsample. So let's say your sound is recorded at 16-bit and you are resampling it to 32-bit. Okay, so you have to basically go and increase the size of it. However, when you're downsampling, so from a 16-bit, you reduce it to 8-bit. So that is an example of resampling or downsampling. Fade-ins and fade-outs, on the other hand, fade sound either at the beginning or at the very end. Sometimes when you are overhearing a song in a radio or probably a digital audio or a digital song, right at the very end, you'll notice that the sound eventually fades out or the volume gets lower. Now, that's an example of fading out. Now, this very similar thing, you can have it at the very beginning of the sound as well. So that is called fade-ins. Equalization. Okay, equalization allows modification of a recording's frequency content so that it sounds brighter. So what happens with equalization is, if you have recorded a sound, so the modification allows the recording to become brighter. In other words, to become more and more clear and to become more and more distinguishable. Time stretching lets you alter the length of a sound file without changing its pitch. So it's just like the way of you are trying to alter this length of the sound file. Either you can make it small, either you can make it big. So more like you're editing it, but at the same time, you're not affecting the quality and the pitch of the sound. Digital signal processing. Okay, what it does is, now, digital signal processing, it is able to process a sound source with effects to add greater value to a project. In other words, you are trying to insert some form of sound effects within the digital audio. And reverse sounds, it is a simple manipulation, reverses all or portion of a digital audio recording. So it's just a way of you are trying to manipulate the sound. Now, how do you manipulate it? Either you can cut the sound into a smaller file, or you can remove some portion. Let's say the sound is worth about 5 minutes, so you remove the first 30 seconds and insert it right at the very end. So this is an example of reverse sounds. Now, the opposite of digital sound is MIDI audio. Not literally opposite, but this is a different type of file type. Okay. So since they are small, MIDI, okay, which stands for Musical Instrument Digital Interface, files embedded in web pages load and play promptly. The length of a MIDI file can be changed without affecting the pitch of the music or degrading audio quality. Working with MIDI requires knowledge of music theory. So with MIDI, what it does is it allows music and sound synthesizers from different manufacturers to communicate with each other by sending messages along cables connected to the device. Now, one of the examples that I can very simply give of MIDI files is the music files that you see on the web. Let's say a new song is just released, and you'll see they use all these sorts of equipments, synthesizers, and amplifiers, and so many different types of equipments to record sound. Now, that is an example of a MIDI audio, musical instrument digital interface. Now, MIDI data is not digitized sound. Now, why we say it's not digitized sound? It is because as such, it is a shorthand representation of music stored in numeric form. So it's not the entire length of music, but shorthand. Now, digital audio is a recording, whereas MIDI is just a score. When we say score and recording, the difference between that is a recording may be very, very long. A score is much more shorter version. Working with MIDI generally requires some knowledge of music theory. So if you do not have some knowledge of music theory, it might be a bit difficult to work with MIDI audio files. So that's an example. So you have a piano over there, okay? And if you look at the document, okay, that's where your music theory comes in, because for you to actually distinguish well which music node goes on what key on the keyboard, you will not be able to play it. And you'll see that you have two more softwares. First one is this, okay, this is one software, and this is another one, okay. And this is an example of a MIDI software. And you notice that the name of the software is Sibelius 6. Sibelius 6 is generally found in Apple Macintosh computers. So it's a MIDI software which comes in free with Apple computers. And you can use it to record MIDI audio. Now, once again, these are music notes for you to actually, music notes, you know what they are? Mi, do, re, sa, ma, pa, and all those things, okay? So when you actually have those notes, when you see this note, you'll have to play it up in the keyboard. So that's where music theory knowledge comes in. So using that, you will be able to play it, and using these two combination of softwares, you will be able to record and have a score done. Now, MIDI is a shorthand representation of music stored in numeric form. It is not a digitized sound. A sequencer software and sound synthesizer is required in order to create MIDI scores. MIDI is device dependent. In other words, now notice that the digital audio is device independent. That means the entire sound depends on the recording and not on the devices. Whereas here in MIDI, it's most likely that this particular recording that you do using MIDI platform, your entire recording is dependent on the device. That means the better your device, the better the sound and the music is going to be. And you may see all the different combinations of softwares again. Now, remember I was telling you about sequencer. Now, this is the sequencer, okay? And the sequencer controls, okay? And you have the synthesizer as well, okay? This is a keyboard which does the recording, and in the back end, you see a software where you're able to edit the audio. MIDI versus digital audio. MIDI is analogous to structured or vector graphics, while digitized audio is analogous to bitmap images. MIDI is device dependent, while digitized audio is device independent. MIDI files are much smaller than digitized audio. MIDI files sound better than digitized audio files when played on a high quality MIDI device. So if you look at some of the differences, okay, so MIDI is analogous to structured or vector graphics, okay. Now, if you look at when it says analogous to structured or analog to structured or vector graphics, in other words, it cooperates well with vector graphics, and digitized audio cooperates well with bitmap images. So what is the difference between the two? With vector graphics, generally these are made out of shapes and stuff, okay, whereas bitmaps, these are photorealistic images. MIDI is device independent. That means they depend on the devices, and the quality of the sound generally depends on the devices itself. Whereas digitized audio is not device, sorry, it is device independent or not device dependent. In other words, it depends on the quality of the recording and not the device. Now, MIDI files are smaller than digitized audio. Why? Because these are just scores, a shorter version, okay? And moreover, digitized audio, these are actually recorded. MIDI files sound better than digitized audio files when played on a high quality MIDI device. Okay, since they are created or since they are device dependent, MIDI files will generally play better when they are played on a high quality MIDI device. There are other differences between the two as well. For example, MIDI files generally they are smaller in size, whereas audio files are digitized audio, sorry, whereas digitized audio is large in file size. Now, why? Because you'll notice that with vector graphics, okay, the very first point, because it's analogous to structure the vector graphics. With vector graphics, what you notice is that the file size is generally smaller, whereas bitmap, so these are photorealistic images kind of sounds, and what they do is basically their file sizes are a bit bigger. Now, also note that it is easy to embed MIDI audio devices, MIDI audio files, sorry. It is easy to embed MIDI audio files in web pages. Why? Because it's smaller in size. And also you can easily go around changing the length of MIDI audio devices as well. Now, disadvantages. If you want to look at the disadvantage part, I'll read this and then I'll explain. With MIDI, it is difficult to play back spoken dialogue, while digitized audio can do so with ease. MIDI does not have consistent playback quality, while digital audio provides consistent playback quality. One requires knowledge of music theory in order to run MIDI, while digital audio does not have this particular requirement. So if you look at the disadvantage, okay, well, with MIDI, it does not represent sound, but musical instruments, okay? So what happens is that with MIDI, it generally goes around creating sounds through the use of musical instruments, example, the piano. Whereas if you look at digital audio, it generally goes around representing the recording in terms of sound and not instruments. With MIDI, the other disadvantage is that it does not have consistent playback qualities, whereas digital audio, it does have consistent playback quality. And the most important one is that if you do not have good sense of music knowledge, you will not be able to run or record MIDI audio. Whereas with digital audio, you would be able to do it without any single bit of knowledge, just a bit of playing around here and there, trial and error, and you should be able to record a audio. Now, recording and editing digital audio. System sounds are assigned to various system events, such as startup and warning, among others. Macintosh provides several system sound options, such as a glass, indigo, laugh. In Windows, available system sound include start.wave, chimes.wave, and code.wave. Multimedia sound is either digitally recorded audio or MIDI, musical instrumental digital interface music. Now, I'm not so sure how many of you actually have access to a Macintosh operating system based computer, but Windows, in any point in time, we all must have used a Windows computer. Now, when you start up your computer, then you have a welcome sound. That's the start file. When you try to, when you have an error, so it gives a doing kind of sound, so that represents error. So this is an example of system sounds. When we talk about system sound, is more likely talking about the operating system sound that are assigned to a particular type of platform. In this case, we're looking at Macintosh and Windows. Audio file formats. A sound files format is recognized methodology for organizing data bits of digitized sound into a data file. On the Macintosh, digitized sounds may be stored as data files, resources, or applications such as AIFF or AIFC. In Windows, digitized sounds are usually stored as WAV files. Now, to make it simple, it's simply like this. We have different types of audio file formats. Now, if you use a Apple-based operating system, so the music or the sound file format that you have is .aff or .aifc. Whereas with Windows, you have WAV files, .wav, you have .mp3, you also have .mp4. Okay, so these are the different types of audio files that you generally have for Windows and Macintosh. Now, MP3 compression is a space saver. Okay, so MP3 is also a sort of a WAV file, but it is a space saver and is generally used for audio files only. MP4 is also used for audio, but together with that, you can get videos streamed together. So generally, you have a video, with it is some associated sound. So the format that you'll be looking at is either .wav or .mp3, sorry, .mp4. But MP4 is largely used because it is able to be played into several types of application softwares. Whereas WAV formats, it has limited type of softwares which can play it. Moreover, MP4 basically is smaller in size. The file size is generally smaller. WAV files, generally they are a bit bigger. Now ACC, now this is used in Apple. Advanced audio coding is used for Apple's iTunes store. So again, I'm not so sure how many of you use Apple computers. So if you're using iTunes and you're trying to get songs or music off iTunes, so the format that you have is .acc. Now, adding sound to multimedia project. File formats compatible with multimedia authoring software being used along with delivery mediums must be determined. What it simply means is the different types of file formats that you are going to use, and when you are creating it, you need to ensure that how compatible it is with the different types of authoring software. Now, authoring software, it means those softwares which are able to edit audios for you. In case of sound, you have Audacity, which can do it for you, and you have Adobe Soundboard. And if you're using Apple, it's Sibelius 6. Sound playback capabilities offered by end-user systems must be studied. Now, the type of sound, whether background music, special sound effects, or spoken dialogue, must be decided. Digital audio or metadata should be selected on the basis of the location and time of use. So when you are looking at adding sound to multimedia, what you're looking at is the type of sound, okay, suitable situational sounds. For example, if you have a video where it shows somebody's clapping, so you need to ensure that you have a suitable audio which demonstrates clapping and not crying instead of clapping. Okay, now you must have additional sound effects. Spoken dialogues, you need to consider them. Okay, if somebody is speaking, okay, what places, how, when, where it will be recorded. Determine the different types of file formats. Which format do you want? MP3, if just in case it's just an audio, or if it's just a audio combination or combined with video, so MP4 or .wav. And you need to determine the file size as well. Now, when determining file size, so if you're comparing WAV and MP4, it would much more better if you go for MP4. Likewise, if you're recording just audio, it's way more better to go with MP3. And then you also need to determine whether you want to have an audio, digital audio, or a MIDI data file. Now, how to determine if something, for example, if it's just instrument music, okay, and you have some theory of basic music, so you might use MIDI. But if you're recording almost anything around, so just go for digital audio. Now, create or purchase source material. So when you are also adding sound, you need to ensure whether you want to create the source material or you want to purchase it. Now, what it simply means is that, for example, if you are trying to edit a photo, so do you want to take the actual photograph using a camera, or do you want to purchase this off the internet or download it from the internet? So very same option here when you are trying to add sound to multimedia project. So whether you want to create the audio on your own, you want to get it off the internet, or you want to buy it from a specific website. Edit the sound to fit your project. Test the sounds to be sure they are timed properly with the project. Very important. Okay, so if you are editing your sound, you need to ensure that sound covers the entire project and not halfway, so that it is blank 5 minutes when it's 5 minutes before even ends. Okay, so you need to ensure they are timed properly and adequately to suit your projects. Recording an inexpensive media rather than directly to disk prevents the hard disk from being overloaded with unnecessary data. Now, what it simply means here is that when you are recording your sound, it's way more preferable to get it recorded and saved in a inexpensive media, example, a flash drive, or probably an external hard drive. When you load it directly into computer's hard disk, there's a likely chance it will occupy a lot of space and slow down your computer system. The project equipment and standards must be in accordance with the requirements. It is vital to maintain a high quality database that stores the original sound material. And keeping track of your sounds. So how do you keep track of your sounds? So to do that, you can have it stored in CDs or discs. It's just sound. When it's just talking about sound and not video, you don't need a DVD. You need a compact disc, a CD. The Red Book or ISO 10149 standard is a standard for digitally encoding high quality stereo. For this standard, the digital audio sample size is 16 bits and the sampling rate is 44.1 kilohertz. The amount of digital sound information required for high quality sound takes up a great deal of disk storage. That's one. Okay, what it simply means is that you can keep track of your sound by storing it in a CD, okay? And you need to ensure to use the acceptable and the standard digital audio sample size, which is 16 bits, and at a sampling rate of 44.1 kilohertz. And you can also keep track of your sounds by storing in your mobile phone, or you can keep it in you can keep it up on a website on the web. For example, you can use Google Drive, you can use OneDrive, and so forth. Sound and image synchronization must be tested at regular intervals. Okay, what it simply means here is when you have an image, for example, you want to have an image and sound playing at the back. So when you're doing it, you need to ensure that you continuously check the image and the playing of the audio at the same time, so that you do not have to go around editing the entire thing all over. The speed at which most animations and computer-based videos play depends on the user's CPU. Sound RAM requirements as well as the user's playback setup must be evaluated. What it simply means is that the amount of the sound that you're trying to record and the RAM that your computer generally has, it needs to be checked and see whether the rate at which you want to record the sound and the quality that you want to have, whether it could be done properly or not. If your RAM size is too small, probably you need to do a bit of changing or upgrading of your RAMs, else the quality would be not so good. Copyrighted materials should not be recorded or used without securing appropriate rights from the owner or the publisher. So if you are recording audio, okay, for example, music. So if you are trying to, okay, let's put it like this, you're trying to record a video, you have done the recording, but you do not like the sound that is displayed. So what you think is you are sort of putting a audio behind it, let's say a music by, let's say, a famous singer like Chris Brown. So if you have a music, so you cannot just put it unless and until you have rights to it. So if you put it on YouTube, YouTube will end up blocking your video, okay, because you can't use copyrighted materials. So if you are using a copyrighted material, you need to get appropriate rights from the owner, or you need to pay some certain amount to get the rights for it. Summary. Vibrations in the air create waves of pressure that are perceived as sound. Multimedia sound is digitally recorded audio, or MIDI, musical instrumental digital interface music. So you have two types of sound, digital audio or MIDI. Digital audio is the actual representation of sound stored in form of samples, whereas MIDI is a shorthand representation of music stored in numeric form. Digital audio provides consistent playback quality. MIDI files are much smaller than digitized audio. MIDI files sound better than digital audio files when played on a high-quality MIDI device. And these are some of the questions that you can actually go around. Sorting out the answers is just for you to test yourself out and see if you're able to answer this. Now, be very careful with these questions. There's a likely chance some of it might be even be tested in your mid-semester exam or any form of quizzes. So please ensure that you are keeping yourself well updated with these questions as well. And this finishes our lecture for week 5. Now, just a reminder, this is the lecture for week 5 and not week 6. Even though I'm recording it week 6, it's for week 5. Why I'm recording it now is just because last week we couldn't have a lecture class because of power outage in my area, so we couldn't have that. So the class was cancelled, and this is the recording for week 5. Now for week 6, we'll have our classes normally, as we have our classes, which is going to be tomorrow, not tomorrow, sorry, which is going to be on Thursday, and Thursday 2 to 4 p.m. I'll see you then. So then please ensure that you're doing well. Okay, also try your very best to get all your mid-semester exams revision up to date, and also go and attempt your weekly lecture-based quizzes. All right, everyone, this is all for week 5. Thank you very much. Binaka.